Hello. So the next question is from question number 19, phase 1, documented of reaction. The question is the mass of P₄O₁ produced if 440 gram of P₄S₃ is mixed with 384 gram of oxygen and reaction is given. So first I write the reaction for you. P₄S₃ with oxygen gives you P₄O₁ with SO2. Try to balance the reaction. P₄S₃, P₄S balance. Okay, fine. Sulfur is not balanced. I'll balance the sulfur here. 3S. Now, oxygen is 10 on right hand side and P₂S₃ on right hand side. Total 16 oxygen on right hand side is actually O only. So 16 oxygen on right hand side. So if I put 8 here, 8 to the 16, reaction is balanced now. Moving to the question, 440 gram. So they have given the mass actually. So what I always prefer is try to calculate the number of moles. Then it is easier to put the stoichiometry. We'll try to calculate the number of moles they have given. First, we'll calculate the number of moles of P₄S₃. So P₄S₃ is P₄S₃. Phosphorus is 31 into 4 plus sulfur is 32 into 3. So 4 was a 2, 1 is a 4, 4 3 is a 12 plus 3 2 is 6, 3 3 is 9, 96 will be there. If I'll add them, so 6 4 10 1, 9 10 12, 220 will be the 220 will be the atomic or molecular mass of P₄S₃. So if I try to calculate the number of moles is 440 gram they have taken P₄S₃. But this is given mass, molecular mass is, we have calculated 220. So 24 number of moles of phosphorus is 2 moles of P₄S₃ will be there. Now mean this is 2 moles. Now calculating number of moles of oxygen. Number of moles of oxygen. If I tried, they have given how many much mass of 384 gram mass of oxygen. 384 gram mass of oxygen. The oxygen number of moles is given mass. So given mass is how much? 384. Molecular mass of oxygen is how much? 16 to the 16 is the atomic mass. 16 to the 32 is the molecular mass. So 32 will be there. So 16 when 16 to the 32, then 16 to the 32, and if I'll check 16 for the 64, and further cut 12 moles of oxygen. 12 moles of oxygen. So we have 2 moles of P₄S₃ and 12 moles of oxygen. We know 1 mole of P₄S₃, according to stoichiometry, I'm telling, 1 mole of P₄S₃ react with 8 moles of oxygen. 1 mole. If I write the basic stoichiometry first, P₄S₃. So 1 mole react with 8 moles of oxygen. That is the stoichiometry. Now, we have how much? We have 2 moles. We have 2 moles of P₄S₃ and we have 12 moles of oxygen. So what I can see that in this case, 1 mole with 8 mole, so 2 mole need 16 moles of oxygen, but we don't have 16 moles of oxygen, means oxygen will be, in this case, will be the limiting reagent, yes or no? It will gonna finish faster in the reaction. So means if I'll tell this 12 moles of oxygen are there, so if I'll see 1 mole of P₄S₃ with 8 moles of oxygen. Okay, this is clear from the stoichiometry. Now I am taking, we know that oxygen is now limiting reagent, so X moles of P₄S₃ with 12 moles of oxygen. Yes or no? So 1 mole of P₄S₃ with 8 moles. So an X moles reacting with 12 moles. If I try to cross multiply is, so 12 equals to 8x. X will be 12 upon 8. 4 2 is 8, 4 3 is 12, or 1.5 moles. 1.5 moles will be. X means 1.5 moles of P₄S₃ is reacting. 1.5 moles of P₄S₃ reacting. So yes, from this stoichiometry, 1 moles form 1 mole of P₄O₁. So 1.5 moles will also form 1.5 moles of P₄O₁. So trying to calculate the things up. So 1.5 moles of, we have N P₄O₁, 1.5 mole. Now, molecular mass of P₄O₁ is how much? Phosphorus 31 into 4 plus 16 into 10. 4 on the 4, 4 3 are 12 plus 160. So 4, 6, 2 is equals to 8 and 2. So 284 is the molecular mass of the compound of the P₄O₁. We'll confirm it once more. 4 in the 4, 4 3 are 12, correct? 60, 160, addition 4, 6 to 8, 284 is the molecular mass of P₄O₁. Putting in the formula, number of moles equals to given mass upon molecular mass. Given number of moles is 1.5 moles. Given mass we have to calculate. Molecular mass is 284. 284 multiplied by 1.5 will be the given mass. 284 multiplied by 1.5 is the given mass. I'll try calculator for you guys. 284 multiplied by 1.5. 284 multiplied by 1.5. It will be 426. Which option? If I'll say 568, 426 is the second option. Answer 426 grams. Clear? So B will be the answer. And in this, the basic concept behind is the uses of stoichiometry. That's it. Okay, so B is the final answer. Thank you.